So I'm going to start with just a quick recap of some of the formulae we saw last time, and then I'm going to come to the worksheet questions. So we saw formula for triangle law of vector addition. So we saw two vectors in terms of the fact that we know the magnitude of the vectors. Yeah, if you don't mind, I will decide what order in which we let me just concentrate on the lecture. I'm sure your faculties are all good enough to know how to teach and what to teach. So given magnitude of the vector A is some quantity capital A, magnitude of vector B is some quantity capital B, and the angle is between them is theta. So now we can find out using what is called the triangle law of vector addition. This particular thing we saw, we can find out the resultant sum of A and B. Okay, so this quantity here, it is called the resultant sum of vectors A and B. We saw that the construction of the vector triangle is done in this way, that you draw the vector A first, the same vector which is drawn above, and from the head of vector A. Okay, so as you've seen that the vector is an arrow, so it has a tail and a head. The second vector which you're adding to it has to be drawn in exactly the same manner that vector was drawn above, but it has to be drawn from this point, from the head of vector A. Okay. The second vector has to be drawn like that. Just give me a second. Okay. At exactly that angle and of exactly that same length that is shown above. So this angle has to be exactly the angle theta, which is the angle between the two vectors, and the length of this arrow has to be of proportionality to its magnitude. The length of this arrow has to be proportionality of its magnitude b, and then the third side that you can draw to complete the triangle. Yeah, Itanshu, this point about notes have been going on and on again. So don't. It is really up to you. You can make your own notes. You can make shorthand notes. As you know, every lecture I'm providing you with the notes in PDF form also. So really your concentration should be on learning and not so much on notes. What is more important is whatever questions I'm doing over here, you solve those questions yourself, especially when I give you time to solve the questions. So then we saw the formula of the triangle law. So the formula was that magnitude of the resultant is given by this formula. It is square root of magnitude of A square plus magnitude of B square plus 2 times product of magnitudes multiplied by cos of angle between them. And this angle alpha is given by the equation that tan of that angle, tan alpha, becomes equal to B sine theta upon E plus B cos theta. So in the last lecture, we have talked extensively about these two formulae, and then we've seen some applications of this. Okay. And most of the worksheet number 1 is about the applications of this formula. Okay. So just make sure you have a quick revision of this. Okay. Now a couple of additional points I want to discuss before we get into more problems. Okay. One is that you should know sine, cos, tan of the standard angles, which I'm sure all of you are aware of. But other than that, there are certain additional angles also that you should know about. Okay. So just aside from our vectors, just a point from mathematics, actually from trigonometry, sine, cosine, and tan of some common angles that you should know about. So I'm drawing some common right angle triangles. Ones that are very commonly used to solve physics problems. So one is this 30, 60, 90 triangle. So if you draw it in this way, that this particular angle here is 30 degrees, then this angle here becomes 90 degrees. Okay. And it has sides such that you know that, sorry, that angle becomes 60 degrees. Okay. Yes, Diti, in that formula, tan will always have to be b in the numerator, because what we are doing in that formula is the angle is calculated for a plus b with respect to a. So coming back to the diagram, if the vector in the base of the triangle is a and you are calculating this angle, then in the numerator it has to be b sin theta, denominator a plus b cos theta. Whereas अगर आप a b को interchange कर देंगे, suppose the vector which is on the base over here is b, so you are finding the angle of a plus b with respect to b, then a and b get interchanged. Okay. Yeah, so then you can find the angle. No? That is about triangle. No? You know theta and you know alpha. So what about this angle? You know how to calculate it by using the fact that alpha plus this angle. The whole point is you want to find out the direction. अभी आपने एक angle अगर निकाल लिया है alpha, then you know the direction of that vector. Okay. Yes, we will be discussing doubts. Hitanshu, I think, I don't know, you seem to be out of sync today. I've been saying from the beginning that I will be discussing the doubts of the worksheet number 1. I'm coming to those doubts. I'm just doing some revision of basic formulae that you will require in this chapter. Once I complete that, I will be solving the doubts, okay, for the nth number of times. Okay, thank you very much. Yes, Tej, tell me, what is your doubt, beta? Yes, Tej, I'm waiting. What is your doubt, beta? I will tell you collinear vectors. Just wait for some time. Okay. Collinear vectors का meaning होता है या तो parallel or anti-parallel. I will tell you about it. Just wait. Okay. So here, sine 30 degrees, okay, is equal to half, which all of you know, which is the same thing as cos 60. So if you invert this triangle, you can see that it's like this. So I'm just reiterating. These are some of the common points that I'm sure all of you know, but you should just have them written down in one place. So this triangle and this triangle are the same, but they are just okay. Then cos 60 degrees, sorry, cos 30 degrees is same as sine 30 degrees over there, and that is equal to root 3 by 2. So sine of 60, so basically you know the connection that sine of theta is always equal to cos of 90 minus theta. And similarly, cos theta is always equal to sine of 90 minus theta. Hence you can see that this thing is 60, this thing is 30, like that. Okay. And then tan of 30, it obviously becomes sine divided by cos, so it's 1 by root 3. So this is one type of triangle that you should know. Okay. Then another type of triangle which will be new for us, which you might not have seen before, is the 3, 4, 5 type of triangle. That is, you know that 3, 4, and 5 are Pythagorean triplets. Okay. So if we draw a triangle where the ratio of the perpendicular and base is 3:4. So the hypotenuse becomes 5, because you know that 5 square is equal to 3 square plus 4 square. Okay. So it just so happens that in this case, this angle is 37 degrees. So this is something new that you'll have to learn. And this angle is 53 degrees. Okay. So sine 37 becomes equal to 3 by 5. Okay. Or you can say cos 53 is equal to 3 by 5. So this is 90 minus theta. Similarly, cos 37 becomes 4 by 5, or you can say that is the same thing as sine 53, because that's the complement of 37. And finally, tan 37 is 3 by 4, or you can say cot of is 3 by 4. And of course, tan becomes 4 by 3. Okay, the 3, 4, 5 right angle triangle, because we will require this from time to time in physics. So it's nothing to do with unit beta. It is just a right angle triangle. So x meters, any such unit possibilities there. Yes, you have to learn this beta. That's it. You have to learn this, just like you move for 30 and 45 and 60 degrees. You have to know this one also. It's important. No, not for 36 degrees, only for 37. I'm giving you the ones that you will need to remember. Okay, I'm giving you all the ones, but out of this, new for you. The previous one you all know. If you like, you can take down the notes from here. Some common right angle triangles. So for example, if we have a right angle triangle like this, जिसका की base is, let's say, 120 meters, and this angle is 37 degrees. Now I say find out the perpendicular and the hypotenuse. So find y and h. Given that this angle is 37 and this angle is 90, so you can use trigonometry here to do this. Nahin beta, 90. Yes, Judge, that is correct. Krish, just pay attention. It is 37, okay, not 53, that angle. Yeah, now it's correct. Good. Yash, that's correct. Kunal, correct. Good. Idanshu, have you got this, beta? Yes, Krish, correct. Okay, good. Yes, Yancy, that's correct. Okay. So here you can just see that if you calculate cos 37 degrees, that from here you know, just from here pick up the value, it is 4 by 5, and that in this particular triangle should be the ratio of this. You can see that the hypotenuse will become 150. Okay. And if you just calculate tan 37, from there you know that it is supposed to be 3 by 4, but here it is that unknown value y divided by 120. So that is telling you that y is equal to how much? 90. So that's it. So now you know that y will be 90 meters and h will be 150 meters. So it's the proportionality of the sides, which will always be 3, 4, 5 if the angles are 37 and 53. That's the important thing. And it's a very easy way to remember this. कि देखो क्या होगा, that when you draw this triangle, 3, 4, 5 triangle, whether you draw it like this, okay, or you just draw it arbitrarily like this, let's say. Draw it like this, suppose. Okay. Now in this triangle, you can see that this is the smaller side, this is the larger side, and this is the hypotenuse. So always the angle which is opposite to the smaller side, that one will be which one? The smaller angle. So E angle 37 hoga. And the angle opposite to the 4x side, that will be the larger angle 53 degrees. Here the way I've drawn the triangle, you can see this is the smaller side, this is the larger side. So smaller side के opposite जो angle होगा वो कितना होगा? 37 होगा. Larger side के opposite जो angle होगा वो कितना होगा? 53 होगा. Okay. Similarly, if I give you a triangle like this now, where something like this. Degrees, but now suppose the sides instead of 3x, 4x and this, the sides are 2x, x and root 3x. Now you can see this is which type of thing. If this angle is theta, you can see what theta should be. Okay. You can see that cos theta is half, sin theta is root 3 by 2, and tan theta is. So this information, यहाँ पे angle कितना होगा? This angle will be 60 degrees, and therefore this angle will be how much? It will be 30 degrees. Yes, that is the thing about trigonometry things. That मैं कितने भी proportion का triangle draw कर रहा हूँ, इतना छोटा सा triangle है 3, 4, 5 का, या इतना बड़ा triangle है, but अगर proportion sides का 3x, 4x and 5x है, और right angle triangle होगा, and the angle 50 and 37. That is the whole point of this. Okay, that is the whole idea about right angle triangles and trigonometry. That is the geometry of right angle triangles. That's the way it works. Just that, like any triangle you draw where the sides are of this kind of ratio, root 3, 1 and 2, it has to be a right angle triangle with what angles? 90, 60 and 30. So just like that, 37, 53 and 90 ka triangle kaisa hota hai? It is 3, 4, 5 triangle. Got it? Simple. Now, just to complete this analysis, one very common triangle which all of you know is the isosceles right angle triangle. Usme kya ho raha hai? The two acute angles are identical and they are 45 each. So the drawing is not perfect here, don't mind, but this side is equal to this side. So this angle becomes equal to this angle. So these two angles become 45 degrees. So if these two sides are x each, then this side becomes root 2x. So as you know that sin 45 is equal to cos 45 is equal to 1 by root 2. Now that is approximately 0.7. Okay. And tan 45 degrees is equal to u. So this is the third. Okay. If you just remember these three common right angle triangles, you will not have difficulties with values in trigonometry. Okay. Make sure you remember these three triangles. So two of them you already know from 9-10. Just make sure that to that knowledge you are adding this one, the 37, 53 one. Okay. So that was about that. Okay, so now let us get on with the worksheet. So please open worksheet number 1, those who have it. The 4 students who are new, don't worry about it. I will send you the recording of the lectures. Just make sure you send me a message that you are a new student and asking for the worksheet and the recordings. I will send it to all of you. Okay. So I think we'll start with question number 4. Nobody seems to have asked anything before question 4. So two forces of equal magnitudes act at a point. The square of the resultant's magnitude is 3 times the magnitude's product. Find the angle between them. So in question 4, what seems to be confusing is the language of the question. So let me explain it to you. The worksheet beta is there on the website as well as I've sent it on the group. If you see just now on your Foundation Builder 2 group, I think Hitanshu has sent it again. Okay, so you will find the PDF on that. Okay. If you have difficulty finding it, just after the lecture, drop me a message. I will help you and send it to you. Okay. So let's look at question 4 of worksheet 1. So it says that two forces of equal magnitude act at a point. Okay, so let us say, suppose one force is F1, उसका magnitude अगर x है suppose, then it implies that the second force F2 is also of the same magnitude. Okay, because both forces are of equal magnitude. This is the information given to us in the question. Okay. Now, additionally, also it is given to us that okay, the square of the resultant's magnitude is 3 times their magnitude's product. So resultant क्या है force का? F1 plus F2. So resultant का magnitude क्या है? This thing. So resultant के magnitude का square क्या है? It is this, and that is equal to 3 times the product of the magnitude. Okay, so this is the square of the resultant's magnitude, and that is equal to how much? 3 times the product of their magnitudes. Okay, so resultant क्या होता है vector का? The resultant of one vector is, of two vectors is the sum of the two vectors. Okay, so magnitude of the resultant is nothing but mod of F1 plus F2. Okay. So magnitude square becomes this, and this is given to us in the question. This is the second thing which is given. Okay. So this is also given is this. So now using these two informations that both the forces are of equal magnitude, this is one piece of information given, and this is the second piece of information given. We have to find the angle between the forces. Right? That's what we have to do. We have to find the angle between the forces. So we have to find theta, that is the angle between F1 and F2. So just use the statement of triangle law. So triangle law, the statement क्या है? That the magnitude of the resultant, that is mod of F1 plus F2, is given to us as what? By the formula, it is root of, instead of A and B, just use F1 and F2. So A square plus B square plus 2AB cos theta, in which we know the magnitude of F1 is equal to the magnitude of F2, which is X. Theta is unknown, but we also know that mod of F1 plus F2 square is equal to 3x square. So this information and this information has to be substituted here. Okay. So what we can do is we can square both sides. Okay. So squaring both left hand side and right hand side of the equation, we have magnitude of F1 plus F2, that is the magnitude of the resultant whole square, should be equal to this thing square, which will just become F1 square plus F2 square plus 2F1 F2. So next all you have to do is you substitute this information, this thing and this thing, just substitute it here. Okay. So on substituting, the left hand side will become 3x square, the right hand side will become x square plus 2x square cos theta. And now all you have to do is solve for theta. Okay. So that's it. The next step now, you can cancel this. So 3 will become equal to 2 plus 2 cos theta, or 2 cos theta is equal to 1, or cos theta is equal to half. So that you know is only possible when theta is equal to 60 degrees. That's it. So that becomes the final answer of the question. Yes, Tej, tell me what is the doubt? Yes, resultant is another name for given for the sum of two vectors. जब हम resultant की बात करते हैं उसका मतलब ही sum of two vectors. Yeah, Hidanshu, just go through the steps. The last part में मैंने क्या किया है, ये जो triangle law का statement है, this part, this is the triangle law. I've just squared both sides. This is the triangle law, and then I've squared both sides of this. Okay. After squaring both sides of that, in this I've substituted F1 and F2's magnitude equal to how much? X. And F1 plus F2 whole square is how much? 3x square. So left hand side क्या हो गया मेरा? F1 plus F2 whole square, क्योंकि given information से कितना है? 3x square, तो यहाँ 3x square आ गया. And F1 and F2 individually कितने magnitude के हैं? X है. So that's it. Now rest is algebra. Take x square common on both sides. So 3 is equal to 2 plus 2 cos theta, and then just solve it algebraically. This step now from here to here, just cancel off the x square, right? Common term on both the sides. Okay, so I'm just showing you from the beginning of the question once. Just take a minute, go through it, ask me if there's any doubt in this. Next, I will discuss the fifth question. If anybody has a doubt in question 1 to 3, 1, 2, and 3, please let me know. Otherwise, I'm coming to the fifth question, and after that, the sixth one. So fifth is actually a very interesting problem, and it's very little to do with vectors. It is more to do with geometry. So I'll be using number of things in that, like similar triangles, Pythagoras theorem, those kind of geometrical concepts. Okay, very good, Hitanshu. So hope you've got the question, the carom board question, the fifth one. Okay, so let's come to this. So there's a 4 feet by 4 feet carom board, which I think is the correct match size carom board, but anyway, it doesn't matter. So let me explain the whole question actually. So this is my carom board, let's say. And as you know that there are 4 pockets. Yeah, I will discuss it on all the 4 corners. In fact, let me just label these. Now, what is happening is one of your coins, let's say your queen, is initially at the centroid or the geometrical center, and you're trying to pocket the queen into this side D, but not directly hitting it like this, but you are trying to make it rebound off the wall. So you want to make this queen have a path which is something like this. You want it to go from here to some point on the wall, such that from that point it rebounds exactly. In other words, मैं चाहता हूँ कि जो queen का path होगा on hitting it from this side, striking it with the striker, it should be like this. Now, if you played carom, all of you know that there is a proper, way to do this. If you aim too much to the right, अगर आपने ऐसा aim कर दिया, यहाँ कहीं उसको hit किया, then it will end up colliding here and going off like this. So it will never get pocketed here. Okay. So you don't want to do that. You want to aim at the correct place. So this is an unwanted path. Similarly, just a second. Similarly, if you hit the coin somewhere here to the left of this point, it will end up going in a path like this. It will hit somewhere here, and it will rebound to some point like this. It will not get pocketed. So you don't want these two situations. You want the situation where you should aim it exactly at the correct point so that neither of these two happen. So how do I find that point? But basically क्या करना है कि suppose this is hit. Just give me a second here. Right. So you have to find the displacement, magnitude of the displacement from the center to the front side. So let us say, the where it is hitting on the front side, उस point को मैं label कर रहा हूँ. Suppose this point is E, okay, and the center point is the centroid, so it's O. So we have to find this, the magnitude of the displacement from the center point to E. Then we have to find the magnitude of the displacement from that point on front to the pocket D. And we have to also find the net displacement. So this is the first part of the question, this is the second part of the question, and the third part of the question, we have to find the net displacement, and that is of course OD. So we have to find these three lengths, and we know that this whole thing is 4 feet by 4 feet. The carom board is 4 feet by 4 feet. Okay. So this is where our geometrical concepts will now come in. So yes, we have to basically find the displacement. Okay. But I'm not going to use vectors notation here for the displacement and all. I'm just going to do a simple kind of calculation. Now imagine that, just to guide me, I'm drawing these lines, which are the bisectors of the sides. And further, I'm labeling the midpoint of the side BC as some point F. Okay. So you can see that this is a right angle triangle. Okay. Now the thing is, because of the symmetry, क्या होगा? ये angle के बराबर होगा. Now why this will be the case? So the hint to you is, the bound from the front wall or the front side, okay, at the point E is like a reflection. It is होता है. So it is when a beam of light reflects of a plane mirror. All of you are familiar with this basic concept, that angle of incidence is equal to angle of reflection. So if something is incident like this and reflects off like this, so this is called the normal at that point. So the principle of reflection is basically a symmetry principle, that this angle of incidence is equal to this angle of reflection. I is equal to R. So if I is equal to R, that means this angle theta will be equal to this angle theta. Theta will be 90 minus I. So that principle will apply for this point here. Even though it's not a reflection of light, but it will have that same symmetry. Okay. So now the moment you're understanding that, now you can see, so therefore you can see triangles OEF. Okay, that is this triangle here. Okay, just follow my cursor. This triangle OEF. Okay, and this larger triangle DEC. These two triangles are which type of triangles? They are similar triangles, and they are similar right angle triangles. So both of them have common angle 90, common angle theta. So OEF and triangle DEC are similar triangles. Okay. So we'll make use of that triangle. So if they are similar triangles, then you can see that OF, that is this perpendicular side, upon CD. So ratio of perpendicular to perpendicular should be ratio of base to base. Okay. Now OF will be how much? It will be 2 feet. Okay. And CD on the other side will be how much? 4 feet. So that is FE is to BC. Okay. So therefore FE is to CD is equal to 1:2 or 1/2. Okay. Now the other thing you can also see here is that if the distance FE is x, then how much is the remaining distance EC? It is 2 minus x. It is 2 feet minus x. अगर ये x है, तो ये 2 minus x होगा. Right? Because this whole thing is obviously 2, no? This is 2 feet. Because this is bisecting this whole side. This is 2 and 2. Okay. So this equation now becomes x upon, sorry, EC. The denominator is EC. This ratio x upon 2 minus x is equal to 1/2. So from this you find the value of x. x2 कैसे होगा? So x you will see is 1/3. Sorry, 2/3. So x will come out to be 2/3. Okay, feet, and the other side 2 minus x will come out to be 4/3. Okay. Or in other words, your FE is 2/3 of a foot, okay, and EC is 4/3 of a. So got this. Okay. Now you find by Pythagoras theorem, you find the hypotenuse. So once you got these two sides, just use Pythagoras theorem for the individual triangles, and you will get the hypotenuse, because that's what we want to find. These OE and ED are nothing but the hypotenuses. Okay. So just take down the diagram first, and once again I'll take you through the application of similar triangles. Just take down the diagram, you'll understand. Take down the diagram and this note about the similar triangles. Yeah, I'll repeat about X. Just take down the diagram first. Yeah, so are all of you clear up to this similar triangle step? This ratio thing you're clear, na? And how this is 2/4, na? Because ये वाला triangle का height is half the side of this thing. Yeah, but I'm explaining that, okay? But first understand the similar triangle statement up to this step. Okay, make sure you understand up to this step. The rest I'm explaining. So this side is 2 foot, na? And this side is 4 foot. So these two triangles have a 2:4 or 1:2 ratio. So now their basis, that is FE, is to EC. FE is to EC. That will also have to be the same ratio. So that has to be 1/2. Okay. Now refer back to that, and you can see that here what I'm doing is, if FE is equal to x, then EC will have to be 2 minus x. Why? Because FE plus EC is nothing but the half the length of the side, na? So it is 2 foot. Just see in the diagram above, if this distance from F to E is x, then this distance from E to C has to be 2 minus x, na? Because what total F to C kitna hai? Half the side length. Is it clear now? Sushant and Tejas, sorry, Tej. Good, okay. Tej, beta, is it clear now the similar triangle application? Okay. So abhi FE को मैंने x substitute किया, some unknown quantity. But the moment is FE is x, what about EC? EC has to be 2 foot minus x. And the ratio of these two, that is now x upon 2 minus x, that ratio has to be 1 by 2. So just cross multiply this and solve for x. You will get the value of x as 2 by 3 feet. And you will get the value of this as 4 by 3. Yes, very good. Now you got the answer correct. Okay. And now use Pythagoras theorem. Okay. So therefore, from this, now you can see that in triangle, the first triangle, OEF, use the Pythagoras theorem. So OE square has to be equal to OF square plus FE square. So OE square has to be equal to 2 square plus 2 by 3 ka whole square. So OE has to be equal to square root of 4 plus 4 by 9. So that will be 2 by 3 root 10. So that is the answer to the first part. The magnitude of the distance, the center point to the front wall where it is reflecting, that point E is this. So this is the answer to the first part. Now obviously ED will be double of that because it's the hypotenuse of the other triangle, and triangles का ratio क्या है 1:2 है. And now you can see that again ED will be 2 times OE using the similar triangle relation. So ED has to be 4 by 3 root 10. Okay. And for OD you don't do the second part, and OD to ठीक है, it's half the diagonal of the square, so that's direct. This is the second part of the question. And the third part of the question, OD is direct. It's just 2 root 2 feet, this one, this side. Just give me a minute, guys. Just reconnecting. Yeah, no, Tej, actually my connection was interrupted for a second, but now it's back. Okay, so done. Yes, any doubt in this, people? This question is clear? Yeah, actually it's raining very heavily in my side, so there might be a bit of lag every now and then, but okay, good. Don't worry, the lecture is recording, so you'll get the... Okay, now let's come back to question number 6 next. Yes, Hitanshu? Anything else, Hitanshu? Any other doubt in this? No? Okay. Achha, Sushant, about OD. Yeah. See, Sushant, coming back here, about the vector OD or about the side OD. अभी देखो OD क्या है? वो is the hypotenuse of the larger triangle. ना? So again, your OD divided by... अच्छा, sorry, OD बोल रहा हूँ. हाँ. OD is this, ना? Is just this side. Is this? So it's half the whole square's diagonal. Or if you take a smaller square of 2 by 2, उसका diagonal है ना? Yeah, Rajat, this was one of the interesting questions. Nee, Divya, this smaller square, na, this one, just follow my cursor here. The smaller square here, this is a 2 by 2 ka square. So OD is the diagonal of 2 by 2 ka square. So it's 2 root 2. Na? Alright, Sushant and Divya, it's clear? Okay, very good. Yeah, good. Alright, now let's move on to question number 6. Just go through the statement of question 6. I'll explain. It's saying that you have something that moves 2 kilometers towards east, then makes a perpendicular left turn, okay, and move 500 meters, and then made a perpendicular right turn and move 4 kilometers and then stop. Okay. So suppose my east direction is towards the right. So starting from this point, you went, let's say, 2 kilometers like this. So this is 2 kilometers. Then you made a turn to your left of 90 degrees. So that would be a turn like this sort of a turn. So your second displacement now is going to be 500 meters. So that's a relatively small displacement, half a kilometer. But after making a 90-degree right turn, so this is your 90-degree right turn. You're turning in this direction by 90 degrees. And you went 0.5 kilometers or 500 meters. Okay. And then again from this direction, you're making a turn, but this time to the right instead of towards the left. So you're turning in this direction. You're turning 90 degrees in this direction. And you're ending up after a displacement of 4 kilometers in that direction, you're finally stopping. This time you made 90-degree turn like that. Okay. So this is your final point. Okay. So let's say this is the point C, and where you started from, that was the point P. You went from A to B, B to, let us say, D or whatever, and then okay. So your net displacement is A to C in my diagram. You want to find out how much the length is C is. That is the magnitude of the net displacement. So you want to find out this length, let's say. This you want to find out. This is your net displacement. ये आपको निकालना है. Let's say S. I want to find out how much S is. So what you can do here, you can use Pythagoras theorem again. Na? Very simple. You can just continue this line and drop a perpendicular from here, and you have a right angle triangle. So you can calculate whatever is required for that. So this right angle triangle, this is 4, this is half a kilometer or 0.5, and this side is 2. So what is S equal to? Exactly. Shift the vectors and then Pythagoras. That will become square root of 36.25. So that is your final answer. Okay, what about 7th question? Yeah, Didi, I've just drawn the diagram in this, you can see. You have gone 2 kilometers towards east, like this. Then you turned left by 90 degrees, went half a kilometer. Then you turned right by 90 degrees and went 4 kilometers. So your final point is this point C. And you have to find the displacement from your initial point A to the point C. So all I've done is I've converted this diagram into a right angle triangle, as you can see. Okay, and I've used Pythagoras theorem for that right angle triangle. Is it clear? Okay. All right. What about 7th question? Does anybody have a doubt in the 7th? Yes, that is one way to do it, Tej. Karan, what are you asking? If we convert square root to, you can do it in point form. It's no problem. You can convert square root 36.25 in some decimal. Yeah, I'll solve the 10th question. Okay. So 7th is easy. I think you've got it all. 8th also some people have asked. So let me discuss 8th question the next. Then I will come to 9th. So 8th question is also easy, but maybe yes, vectors initially has the application of Pythagoras theorem and trigonometry, both the things a lot. That's why I've discussed the 3 specific type of right triangle triangles today, because there's a lot of trigonometry and Pythagoras theorem in this. So anyway, if you look at the minute hand of a clock, that is what the 8th question is about. So 60 or 0, whatever, 15, 30, 45. So these are the minutes in the clock. Now, anytime your minute hand moves 15 minutes, what is the displacement of the tip of the minute hand? That is what has been asked in this question. Okay. You have to find, so it's given to us that the minute hand of the clock has a length of, how much is it given? 10 centimeters. Okay. We have to find the displacement of its tip, the magnitude of the displacement of its tip in 15 minutes. Okay. So let's say my minute hand is this particular thing that I'm drawing. Is this. At some point of time, it's somewhere. Okay, let's say this is the minute hand and this is the hour hand, let us say. So let's say right now the time is something arbitrary. Okay, so let's say it is 12:07 p.m. Okay. Now from here, I'm going 15 minutes. So the time is now becoming 12:22 p.m. So as it goes like this, the minute hand moves to which point now? The minute hand moves to here. The 22 will be somewhere here. But more importantly, the exact angular displacement of the minute hand you will see will be 90 degrees. If this is going from, if I draw an exact diagram where this is going exactly from 7 minutes to 22 minutes, then this should be 90 degrees exactly. Okay, this should form a right angle triangle. So this is what will become, this one that I'm drawing here. This will be the displacement of the minute hand in minutes. It will exactly be the displacement. So if this length is 10 centimeters, you can see that this displacement will be how much? L. So the displacement of the minute hand stick in 15 minutes will be L root 2 or 10 root 2 centimeters, which you can approximate as 14.1 centimeters. Similarly, the displacement of the minute hand stick in 30 minutes will just become one diameter. So in 30 minutes now the minute hand would have reached here, and like that. Quarter of an hour, so quarter of an hour is 15 minutes. So actually the interesting thing is whether you go from 12 to 12:15, okay, or you go from let's say 12 to 1:15, even then the displacement is the same. Even then the displacement of the minute hand it will only be L root 2. Because it's not distance, right? It's just displacement. Quarter of an hour is the same as 15 minutes. So yeah, Tej, you can solve the carom board sum with vectors also, but you have to learn component algebra of vectors for that. So that will come 2 or 3 lectures later. Okay, so right now what we have learned of vectors, based on that, this is the method of solving. And moreover, that will be even much more complicated. The simplest way of solving it is by using the geometry method, which I showed you. Anyhow, so this is done, I hope, 8th question. Now let's move on to 9th question. हाँ 30 मिनट्स में देखो 30 मिनट्स में मिनट हैंड कैसे मूव कर रहा है जाना in 30 minutes. Suppose at some point of time the minute hand was here. Suppose it was here, some arbitrary time. So 30 minutes later, half an hour later, it will be here. No? Exactly diametrically opposite. No, not necessarily. I'll explain. So what is the displacement of the tip? Is this whole thing? Okay. Yeah, Tanshu, coming back to your point, see, the language of the question is important. What is the displacement of its tip from a quarter after the hour to half past? So it's more specific. So quarter after the hour to half past is from 15 to 30. Na? So baat to barabar hi hai na? From 12:15 to 12:30 or 1:15 to 1:30, whatever it is the same. Na? So this is where it would be at 15 past the hour, and this is where it would be at 30 past the hour. So it's just a specific case of 15 minutes. But what I'm saying is actually in any 15 minutes it will do the same. And 0 to 45, for example, 0 पे यहाँ पे होगा, 45 पे यहाँ पे होगा. So again, actually it has moved like this, the thing. But what about the displacement? The displacement will be only this, because displacement is defined from initial to final. Understood na, Bhavesh? So 45 minutes में actually magnitude of displacement will be the same thing as 15 minutes में क्या होता है. Okay. even though the distance covered in 45 minutes is 3 times the distance covered in 15 minutes, but as far as displacement is concerned, it's the same. So again, this is just to show you the difference between the vector quantity of displacement and the scalar quantity of distance. They are two different things. So let's come to ninth question. Now, ninth question is the one which is the slightly tricky question in this. So let's understand the language of the question very carefully first. So pay attention to exactly the language of the question here. So what it is saying is that if we have two vectors P and Q, unka resultant sum is R. Okay, so the first information given to us that P plus Q is equal to R. Okay, now it is also saying that if I reverse the vector Q, so now remember on the first day we had discussed the relation that when we multiply a vector with a number, what happens? If that number is negative, the vector becomes opposite in direction. Okay, so similarly over here, agar vector Q aisa hai, if this is the vector Q, then what is the vector minus Q? Minus Q kaisa vector hoga? Minus Q will be a vector. Minus Q will be opposite to the vector Q and same magnitude, because you're multiplying it with minus 1. Yeah, you have to prove LHS is equal to RHS, that's fine. Okay, but this is how you do it. So the vector minus Q will be like this. It will be exactly same length as Q, but opposite in direction. But minus Q as well. So minus Q is a vector which is opposite to Q, but of same magnitude. Mod of minus Q is the same as mod of Q vector, which is capital Q. But direction is opposite. Okay. Now in all of this, suppose the vector P is this one. The vector P is suppose this one. Now what else it is saying that this is one thing that is given. The other thing that is given that if you add the vector minus Q with the vector Q, with the vector P, then we get the vector S. So this is also given. Okay. And now we have to prove that R square plus S square is equal to 2 times Q square plus Q. This we have to do the proof of. Okay. So let us see how we can make the triangle. So both of these are sums. Okay. So use triangle law for the relation R is equal to P plus Q. So what this tells us that magnitude of R is equal to magnitude of P plus Q, where this is root of P square plus Q square plus 2P2 cos theta, or we can say R square by squaring both sides is P square plus Q square plus 2P2 cos theta. This is our first. Now we also want to use, so what is the corresponding triangle for this one? The corresponding triangle is this. ये अगर P था, ये वेक्टर Q है, और ये एंगल यहाँ पे थीटा है. So this vector here is becoming R. And last time we saw that how this relation was derived. It was derived by dropping a perpendicular here, taking this side as X, this side as Y, like this. So we saw that because this is Q, so how this was derived, basically X was equal to Q cos theta, Y was equal to Q sin theta, and R magnitude became square root of P plus X whole square plus Y square. And on substituting these over here, we got this one. This was the method that we saw last. Now we'll do something very similar, but for which operation, the second one, which is S is equal to P plus minus Q. So now use a similar kind of relation. So let's derive a similar relation for the operation S is equal to P plus of minus T. Okay. So given those two vectors P and Q now, you see that if P was this vector and Q was in this sort of direction, making an angle theta. So where is the vector minus Q? The vector minus Q will be in this direction. So here, my vector minus Q will look like this. It's exactly opposite to Q. Same in magnitude, but it's opposite to Q. So this is the vector minus Q. So this angle here will be theta because this angle was theta. And finally, which will be the vector S in all of this? The vector S will be this one. This is your vector triangle for the operation which I have written above. P plus of minus Q is equal to S. Now in this operation, how we'll find this side? Again the same thing. Drop a perpendicular here. So drop a perpendicular. Suppose this is X. So this side will become how much? It will become P minus X because the whole base was P. And this side is Y. Let's. So again you have X is how much? X is Q cos theta because cos theta in this triangle you can see this side is Q is X by P. Yeah, I am also doing left hand side equal to right hand side only page beta, but you have to solve the left hand side now. The recording is happening of this lecture there. I will send it after the session. And similarly, sine theta is equal to y divided by q. So y is how much? It is equal to q sine theta. Now apply this in this triangle over here. So how much is S this side? S is equal to square root of p minus x whole square plus y square. Yeah, fine, Tej. You've done that, that's good. So now substitute these values. So p minus x is becoming how much? P minus q cos theta ka whole square. And y is how much? Q sine theta ka whole square. Okay. So this will become how much? This will become p square minus 2pq cos theta. The same method of derivation, but only there will be a minus sign with the cos theta term. Plus p square cos square theta plus this term is q square cos square theta. And this term is q square sine square. So use the identity that sine square plus cos square is 1. So this term becomes how much? It becomes square root of p square plus q square minus 2pq cos. So finally, we are getting the magnitude of S like this. So S square is how much? It is p square plus q square minus 2pq cos. So now from equation 1 and 2, you can see that the left hand side of the proof that you can ask, that is r square plus s square, is how much? It is equal to p square plus q square plus 2pq cos theta plus p square plus q square minus 2pq. This is what was your r square from above, equation number 1. And from equation number 2, what is your s square? Okay. So open this bracket. So it becomes 2 times p square plus q square. that is nothing but the right hand side, and hence 2. Yeah, I'll send the note. As soon as the lecture is over, I will send the notes and the recording very soon with you. I know heavy rains might be disrupting the internet for many of you, so don't worry. As soon as the recording is uploaded, I will send it to you. So just go through the whole thing again once. I'm just putting it up from here. Okay, so just go through the steps which I've used for first expressing r square. So r square कैसे हो गया? Equation 1 से हो गया, which is coming from just application of triangle law. P plus Q is equal to R. But next I have had to derive a similar law to get the second thing in the left hand side, that is S square. S square कहाँ से आया? उसके लिए I had to make a second triangle where I'm adding the vector P with which vector? The vector minus Q, not the vector Q. That's where this comes. So deriving a similar relation here for the operation P plus of minus Q. Like we derived an equation above for P plus Q. Like that, we are deriving a relation below. We are deriving the relation for P plus of minus Q using the triangle. So just write down the steps for the second triangle relation that we got. Okay, people, so hope you understood these steps. Because without that, how will we prove that left hand side is equal to right hand side, na beta? See, Chana, we have to get the value of R and S both in terms of P and Q, na? तभी तो हम प्रूव कर सकते हैं ना, because left hand side is R square plus S square, right hand side is in terms of P and Q. So how we'll get the relationship between them? So see, basically, Malvika and Chana, both of you pay attention here. तो क्या हो रहा है, देखो मेरा वेक्टर P ऐसा है, मेरा वेक्टर Q ऐसा है, तो मेरा वेक्टर माइनस Q ऐसा है. This is minus Q, and this angle is theta. Now from this I need to find out R square and I need to find out S square so that I can prove that left hand side is equal to right hand side. Right hand side is in terms of P and Q. Left hand side is R square plus S square. Right? So to prove that, I have to find the relation between these. So how I find the relation between R, P and Q? By using this. And how I find the relation between S, P and Q? It is this. So this, but I need to work this out. Na? So that is where the triangle thing comes in. Okay, so to prove this, you need to understand that when you are doing P plus Q, R is the third side of this triangle. So R is this one. And similarly, when you are doing P plus of minus Q, then you are doing this operation. This is the vector P, but minus Q is this one. This angle is theta. And this vector here is S. So now to get this thing, to solve this, we need to solve each of these triangles. This triangle and this triangle. Now this triangle solution we already know, so we don't need to repeat it. But the other triangle, how do we solve it? In a manner very similar to how we had solved this triangle. इस ट्रायंगल को हमने कैसे सॉल्व किया था, यहाँ से परपेंडिकुलर ड्रॉ किया था और इसको x लिखा था, इसको y लिखा था, and we started by solving this triangle. Okay, and we saw that in the larger triangle r became square root of p plus x whole square plus y square, where from the smaller triangle x was q cos theta and y was q sin theta. A very similar thing we will now do in this one. We will drop the perpendicular here, and in this triangle, we'll first see this side is x, this side is y. So now this side becomes p minus x. So what is our unknown quantity here? The magnitude of s. Magnitude of s is becoming how much? P minus x whole square plus y square. Where again, what is x? It is q cos theta, and what is y? It is q sin theta. So again, this triangle, this hypotenuse is magnitude is q only. Just like in this triangle, the hypotenuse is magnitude is q. So now actually you can also derive it in another way. You can do this in terms of xy also. Now see, from here and here, you write what is your p square plus, sorry, what is your r square plus s square. R square plus s square कितना हो जा रहा है? This plus this, so it is just p plus x whole square plus y square plus p minus x whole square plus y. We can see that it is 2p square plus 2x square plus 2y square. Now just substitute x square. So that's another way of doing it. This will give you 2p square plus 2q square cos square theta plus sin square. So many different ways of expressing the final proof of it. But the important thing is how to get the relation between the left hand side and the right hand side, because left hand side is in terms of RS and right hand side is in terms of PQ. So you have to get that relation by solving the two triangles. That is the whole point of the question. Anybody else has a doubt now? Kunal, what is the doubt you have sent, Beta? You just yeah, if you wrote directly S as that, it's okay, Beta. But that, how did you know directly? That is the whole point. Because हमने इसके पहले कौन सा फॉर्मूला पढ़ा है? P plus Q के लिए पढ़ा है ना? Vector P plus vector Q. But we have not studied any such formula directly, na? So that is the point of why I went into the whole triangle analysis. Okay, so Malvika, Tej, Kunal, I think all of your doubts are clear now in this. Good. Yeah, Tej, I'm coming to 10th question. That's the final one. Exercise. Chana also clear. Alright, so when you get the notes for today's class and the recording, make sure you go through the discussion of this 9th question very carefully. This is the one tricky question in the whole assignment. Rest of the questions are pretty normal questions. One or two might be lengthy, okay, but the really technical question is only the 9th one. The rest of the questions are easy. Now 10th, again, let us understand. 10th is similar to another question we did earlier, so you might be able to do it now. It says the resultant of two vectors of equal magnitudes of 10 each is also 10. So let us say two vectors are there whose magnitudes are equal and they are 10. This is given. Okay. And also that the resultant's magnitude, that is A plus B ka magnitude, be 10. This is also given. So now from this, what we have to do? We have to find the angle between the two vectors and what is the angle that the resultant makes with each of the vectors. So we want to find theta, that is the angle of E with respect to B. That is the angle between the two vectors A and B. And we also want to find alpha, the angle of the resultant with respect to E. No, it will be 120. I'll explain why the answer is 120. See, if you think about it, okay. Now this is the thing. If I go by the formula method, as of now I will get stuck. I'll show you why I will get stuck. Okay. I'll teach this next part to you today. But if you go by the formula method, as of now I'll get stuck because I'll use the formula magnitude of A plus B should be equal to root of A square plus B square plus 2AB cos theta. So in this I will substitute mod of A plus B as 10, mod of A as 10, mod of B as 10, and theta is the unknown quantity. These three things are given. So substitute and see what you get. You get a very funny result. You get that 10 is equal to square root of 10 square plus 10 square plus 2 into 10 into 10 into cos theta. You get the result that 10 is equal to 100 plus 100 plus 200 cos theta. Or you get the result that so you can square both the sides. That means cos theta is minus 1. As of now, I'm stuck. I don't know what to do from here. How can cos theta be a negative quantity? It turns out it can be, okay. But suppose we don't know, because we don't know trigonometry of that kind of angle where cos theta is negative. Definitely it is not 60 degrees. It's definitely not 60 degrees because I know cos 60 is half, it is not minus half. Okay. So in trigonometry, you've done very good. Okay, but so from trigo, you should know that cos of 180 minus theta. You know this formula, then it's fine. It's minus cos theta. Okay. So very good. If you know that, there's no problem. So 180 minus 60 is minus cos 60. So that's minus half. So cos of which angle is minus half? It's 120. If you know this, then it's fine. Now you know that theta is 120. Okay. But admittedly, I have not discussed this case with you yet. In fact, that is going to be something that we'll discuss in the last part of the lecture today. Okay. But there is a way around this. अगर मुझे ये नहीं भी पता ना कि cos 120 minus half होता है, या ये formula नहीं भी पता है, second quadrant का formula नहीं भी पता है, that cos of 180 minus theta is minus cos theta. Even then, there is a method of solving this. Okay. And that method is the geometrical solution. If I go by geometry, now I can see that the resultant of a plus b, now this is such that this resultant is also 10, a is also 10, and b is also 10. That means the vector triangle is what kind of triangle? Is an equilateral triangle. Okay. So when I draw the geometrical solution of this, it should be like this. The only triangle that will satisfy this given condition, that A, B and A plus B are forming an equilateral triangle. This one, if this is A, then B will have to be this. B will also have to be of 10, so that the resultant of A plus B now is also 10. Has to be like this. So if this is now the case that the three sides are equal, that means each of these angles is 60. 60, 60, 60. So what about the angle between A and B? That is this angle. So the angle theta between A and B is 120 degrees. So theta is equal to 120 degrees. And the angle that A is making with A plus B is 60 degrees. Don't make the mistake of saying that theta is 60 here, because A is a vector pointing in this direction. A ऐसा है और B जो है ऐसा vector. B is a vector like this. So the angle between them is not 60. The angle between them is 120 degrees. They are 10. So this is by the geometry. That's also pretty easy method. So just by recognizing that it's an equilateral triangle, you immediately get that theta is this and alpha is 60. And of course, here by the formula method to prove that alpha is 60, now you have to also use this formula. Tan alpha is b sine theta upon a plus b cos theta. So again, here you will need the trigonometric formula that cos 120 will be minus cos 60 or minus half, whereas sine 120 will be positive of sine 60. So that is root 3. And A is equal to B is equal to 10. So when you substitute all that over here, you will get tan alpha equal to root 3. So that will tell you that alpha is 60 degrees. This last line I've just squared both the sides. So from here to here I've just squared both the sides. So 1 square is 1 only. Baki sab is just algebra. Okay, people. So hope you have followed up to this point. Okay, just give it a reading from the notes also once. So if anything is not clear after that, you can ask me a doubt later also. Doesn't matter. Understood? Okay. So now we come to the next part about vector addition. So in continuation of vector addition, by triangle law, we understand that the angle theta between two vectors can be up to 180 degrees. It has a range of 0 to 180 degrees. Whereas we have the formula is, and tan alpha is b sine theta upon e plus b cos theta. So therefore, we must know how to substitute cos theta and sine theta for not only acute but obtuse angles also. For obtuse angles also. You're already familiar with the formula, so it's no problem. Because we can have a situation where two vectors are like this. So theta is less than 90. There's no problem here. A and B are like this. Theta is an acute angle. But if we have a situation where, let's say, A and B are like this, like this. So theta is now greater than 90. It's an obtuse angle. Or we can have a situation where the vector E and the vector B are exactly opposite in direction. So theta has the maximum possible value in that case. In such a case now, this is B. Theta is 180 degrees. This is the maximum possible theta. 180 से ज़्यादा नहीं हो सकता. Or if A and B are parallel, then it's 0. So in the application formula, we should know how to substitute cos theta and sin theta for a range of theta between 0 and 180. Okay. But from trigonometry of right angle triangles, okay, cos theta is base upon hypotenuse. Sin theta is perpendicular upon hypotenuse. Okay. So how can theta be obtuse? कैसे हो सकता है? Right angle triangle में each angle already 90 है, so theta is always less than 90. So what do we mean by theta being obtuse? How do we solve for that? Okay. So that is where your other interpretation of trigonometry comes in. Okay, so as it applies, okay, so what we have to understand that sin theta, cos theta, and tan theta are defined in a different way when theta is obtuse. So they are defined in this kind of manner that suppose we have a coordinate frame. Yeah, that will be there in your notes better. Don't worry. Pay attention on this part. This is the important thing. How will we define sin theta and cos theta when theta is obtuse? Okay. So suppose we have some line which is inclined like this to the x-axis. Theta is acute. and this is of length L. So when you drop a perpendicular on the x-axis, this quantity x is positive, right? Yeah, ASTC, just explaining the logic of that. And this quantity y is also positive. And sine theta becomes y upon L. So y is positive, remember. So sine theta is positive. Cos theta is x upon L. So x is positive. And tan theta is y by x. So that is also positive. Y by x is positive. So that is why you have E in first quadrant. In quadrant 1, sine, cos, tan, all of them are positive. Okay. But when we take in second quadrant, the interpretation becomes different. In second quadrant, what happens is, now if you rotated your rod or whatever object like this, but at an obtuse angle with respect to theta, I mean with respect to x-axis, इसको ऐसा rotate कर दिया. So now it's in second quadrant. So theta is greater than 90, less than equal to 180 degrees. So second quadrant angle. Okay. So now what is happening? If this rod is of length L, the x coordinate of this end of the rod is becoming a negative x coordinate. So when you drop this perpendicular this time here, इसका जो x coordinate है ये वाला, this is negative. Okay. Whereas the y coordinate is positive. Okay. So once again, the definition of sine theta will be the y coordinate divided by L, but y is positive. So sine theta is positive in second quadrant. But the definition of cos theta is base upon hypotenuse, but the base is now a negative x coordinate. So x being negative, what happens is cos theta becomes negative. And similarly, tan theta is perpendicular upon base. So again, it becomes negative. Tan theta becomes negative. Okay. So that is why in second quadrant, we say it is in quadrant 2. We say it is S because only sine is positive. So that is your ASTC. By similar logic, you can show that here tan is positive and here cos is positive. Okay. And not only that, now you can see that how to find the value. So if this angle, okay, is some acute angle, let's say beta, so you can see that, okay, cos beta, it will be the magnitude of the base divided by the length. Okay. So cos of 180 minus theta is equal to magnitude of x by L. So therefore cos theta is x by L, which will be minus of mod x by L. So that's why your cos theta becomes minus of cos 180 minus, because the x coordinate is negative. So that's why. Whereas you can see over there sine beta is magnitude of y by L, but y is positive. So y is equal to mod 1. Whereas here x was negative. So x was equal to minus of mod x. So sine of 180 minus theta is equal to y by L, which is sine. So we have the formula that sine theta is sine of 180 minus theta. Whereas cos theta is cos of 180 minus theta. Yeah, with respect to s. Okay, so now from this you can see that divide the two. So tan theta becomes sine theta by cos theta, or that is the same thing as minus tan 180 minus theta. So that's how for the second quadrant we have the formula. So for theta between 90 and 180 degrees, second quadrant, the formula becomes this, that sine theta is sine of 180 minus theta, but cos theta is minus cos of 180 degrees minus theta, and tan theta is minus tan of 180 minus theta. Okay. Yeah, I'll explain it. Just give me a second. Okay. So for example, how much will be cos of 135 degrees? Okay. Cos 135 will become minus of cos 180 minus 135. That will be minus of cos 45. So that will be minus 1 by 2. Similarly, suppose I ask you what is going to be tan 120 degrees. We'll use this formula. Tan 120 will be minus of tan 180 minus 120, which is 60. So it will become minus root. Similarly, if I ask you what is sine of 127 degrees. Okay. So sine 127 will be equal to sine of 180 minus 127. So that is sine 53 degrees. It is 4 by 5. Yeah, complete rotation is 360 degrees, but 360 is same as 0 because cyclic. No? But actually, right now I'm not talking about third and fourth quadrant. I'm just talking about the second quadrant. Don't worry about complete rotation. So see, cos of 180 minus theta is mod x by l. Okay. So cos theta is how much? By definition, it is x by l. Cos theta, okay, see the definition of cos theta, it is x by l. So we x actually kya hai? Minus of mod x. But when I take sine theta, which is y by l, what is y? It is mod of y only. It's not minus of mod y. So that is why sine theta is positive of sine 180 minus theta. But cos theta becomes minus of cos. Minus of cos 180 minus theta. Understood, beta? See, cos theta will come out to be a negative quantity because it's the ratio of the x coordinate divided by this length. Now the x coordinate is what kind of quantity? It is negative, no? So this x over here, this x in this formula, it should be replaced with what? It should be replaced with minus of mod x. Now mod x by l is what? Cos 180 minus theta, or this cos beta term. So therefore cos theta is becoming how much? Minus of cos 180 minus theta. But similarly on this side, when you talk about sine theta, y is mod by l. So sine theta, which is y by l, is nothing but mod of y by l, which is nothing but sine of 180 minus theta. So sine theta is positive of sine 180 minus theta. Is it clear, Diti beta? Why mod x is replaced? I mean, x is replaced with minus of mod x, but y is replaced with positive of mod y, because y is a positive quantity in the second quadrant, but x is a negative quantity. Right. So that is the critical reason why In your second quadrant, sine remains positive, whereas cos and tan become negative. And that's how you get these formulae also. That these three formulae used for sine, cos, tan, they are distributed. Okay. So just make a note of these formulae, and we'll see its application in vector addition next. Okay, so from this point onwards, just make sure that you remember these three formulae. This is the important thing. These are the formulae for second quadrant. Make sure you remember these. So make sure you have these formulae properly written down, and then also take note of these examples. And while you're writing these examples, tell me one more. What will be cos 180? Okay. What will be sine 180? And what will be sine of 150 degrees? Just tell me these values. Yeah, Tej, all your questions are actually answered if you just go through the module once. The module has in-chapter exercises, main exercises, everything. So you'll see the level of questions. Yes, correct. That's correct. Kunal, that's correct. Yash, correct. Second one, correct. Diti. Good. So you should be getting this as -1, as most of you are getting. Okay. Very good. Yes, that's correct. Diti, this is 0 as you have said. The second one is 0, correct, Kunal. What about the third one now? Sine of 150 degrees. Yes, half. That's correct. Yes, half is correct. The correct answer, 1 by 2 or 0.1. So just have to use these formula, nothing else. So I'm just writing down here. So cos of 180 will become minus of cos 180 minus 180. Oh, that's minus cos 0. That's -1. Whereas similarly, sine of 180 will be sine of 180 minus 180. So that's sine 0, which by definition is 0. And similarly, sine of 150 by similar logic will become sine 30, which is half. Alright, so now that you are familiar with these formulae to a certain extent, let us see the application in vectors. Very simple example to start with. Magnitude of E is 10 units. Magnitude of B is 10 root 3 units. And theta is equal to 150 degrees. That is the angle between A and B. So find the magnitude of A plus B and the angle alpha of the vector E plus B with respect to the vector E. So very simple, just use the formula. I use formula based method to calculate the triangle law. And now that you know how to substitute cos theta and sin theta for obtuse angle, you can easily substitute them. So just work this out and tell me the answer quickly. Mod A plus B you're getting as 10. Yes, that's the correct answer. Yash and Diti correct. Tej correct. Shweta correct. But Yash, you have to check your solving once. Same Hitanshu, check your solving. Malvika correct. Krish correct. Kunal correct. So you should be getting this as 10 units. And this you should be getting as 60 degrees. Correct, Shweta, that's good. So just apply the formula here. So magnitude of A plus B, the same old formula. Where magnitude of A is 10, magnitude of B is 10 root 3, and theta is 150 degrees. Okay. So from this you'll see cos theta should be cos 150, okay, which will be minus cos 30 degrees. So minus root 3 by 2. So cos theta has to be substituted as minus root 3 by 2. So do that substitution, you'll get the answer. Okay. These are the steps. Okay. Angle बेटा 60 आएगा. कुणाल 60 आ रहा है कि 120 आ रहा है? 120 आ रहा है. Good. It is 120 actually. You're correct. The angle is not 60. Kunal, you're correct. The angle is 120 degrees. Now we'll understand why. Because your tan alpha will come out to be a negative quantity. So when you substitute in the second formula, tan alpha is b sine theta upon a plus b cos theta. So from this you can also see that sine theta will be sine 150, which is equal to positive of sine 30. We just saw that's equal to half. So tan alpha here will become 10 root 3 into half, that's your numerator, divided by the denominator will have 10 plus 10 root 3 into minus root 3 by 2. Remember cos theta is this. Okay. So this becomes 5 root 3 divided by 10 minus 15. Okay. So your tan alpha becomes 5 root 3 upon minus 5. Or tan alpha becomes minus root 3. So the moment you're seeing this is the case, you know that alpha is an obtuse angle. So therefore, you know that tan 60 is root 3. Therefore, tan of 180 minus 60 is minus root 3. So tan 120 degrees is minus root 3. So alpha is equal to 120 degrees. Okay, people. So hope the example of the application is clear. Yeah, I will be sending you a worksheet like the last time for the homework. But I'm not finished. Just one more thing. I'll just take a couple of 5 minutes more. Just take 5 minutes more to understand one more thing. Good to know, Kunal, that you're enjoying it. Okay. Now, one last thing we will see is difference of two vectors. And this will not be difficult because we have seen this through an example today. But it's a different triangle law. This is triangle law for difference, not for sum. So when we want to do this operation A minus B, we interpret it as the sum of A plus of minus B. Okay, so that's the trick that we use over here. Okay. So if this is the vector A and this is a vector B, such that the angle between them is, this angle is theta, then as we discussed in that example earlier, minus B is the vector which is opposite to B but of same magnitude. Okay. So the vector minus B is such that magnitude of minus B is the same thing as magnitude of the vector B, but direction is opposite to B's direction. Okay. So minus B is therefore this vector now. Minus B is this one. So hence, now my operation of A plus of minus B or A minus B, the way I have interpreted it, it becomes like this. It is the addition of the vector E with the vector minus B, which will be this one. This will be the vector minus B. So the angle between the vectors A and B in the original case was theta. ये angle अगर theta था, so what is the angle between these two vectors now? It is 180 minus theta. Okay. So the summation of these two vectors, which is this one here, will come by adding two vectors whose magnitudes are A and B, but the angle between them is 180 minus theta. So the third side of this triangle, this is also vector triangle, but only thing is instead of adding A and B, we are adding A with the vector which is negative of B. Okay. So that is why the angle between the vectors A and minus B is becoming 180 minus theta, where theta was the angle between the vectors A and B. So this is the vector A minus B. And suppose this angle is beta. So these two we can now find out by using the same formula. But in that formula of triangle law that we used before, we have to replace theta with what? We have to replace theta with 180 minus theta. Okay. So magnitude of A plus of minus B, ये जो वेक्टर है इसका मैग्नीट्यूड क्या हो जाएगा? और that's the same thing as A minus B का mod. ये क्या हो जाएगा? It will be root of this vector's magnitude square plus this vector's magnitude square. So A square plus B square plus 2AB, but into cos of which angle? The angle between these two vectors, which is 180 minus theta. So that cos theta term will be replaced with 180 minus theta. And now use the identity that we just saw. Use the fact that cos 180 minus theta is minus cos theta. So this gives us the new formula that this is root of A square plus B square minus 2AB cos theta. So this is the second part of triangle law, which gives us the difference of two vectors. The first part was the sum or the resultant of two vectors. Now this is the second part which gives us the difference. Okay. So just note this down. Just give me a second, people. I'll reshare the whiteboard. It's hanging up a little bit, so just give me a moment. I'll reshare it. Just a moment. I'm rebooting it and sharing it again. So this is okay. So just make a note of this. This is the second part of triangle law, which gives us the difference of two vectors. Okay. So that will be the conclusion of today's lecture. And as for every lecture, I will send you the recording and the notes and a worksheet. This will be worksheet 2. And the 3 or 4 students who have joined newly, don't forget to send me an individual message separately so that I can send you the recordings and the notes for the first 2 lectures. Alright. And be sure to go through particularly question 9 and some of the other questions, the carom board problem, etc. carefully from the solutions that we have discussed in class today. Right? So that's it from my end, people. Yeah, that's okay. The internet connection is very weak for most people today because of the heavy rains. So unfortunately, they will have to depend on the recordings. So it's fine, don't worry. So that's a lot. That's all for today. Thanks, guys. Thanks for attending and wish you all the best. Hope you enjoyed the lecture, and be sure to work out the homework problems for the next time also. Good to know Tej. Thanks. Good to know Kunal.